Hello, this is a video on displaying waveforms in Unreal Engine 5. What I wanted to achieve is something similar to like a DAW has, where you see the WAV file displayed like this, but recreating that in Unreal. As a little demo, what I'm going to do is I'm going to spawn into the world, and this here is a mesh which is going to act as our canvas for the waveform. And if I load new waveform, so I've got 3 files here. I've got a stereo recording, mono recording, and an ambisonics recording as well. So if I load up this stereo recording, so what it's done is it's analyzed the file, given us all the sample data to then display that waveform. So then what I can do is load another waveform. So if I go to the ambisonics recording, open that, and it automatically partitions this canvas for the amount of channels. So if I go to the mono recording now, it displays that as mono. And one other thing that we can do here with this is we can change the resolution of it. So at the moment, what it does is it takes all the samples and then it divides the total samples by this wave resolution. So it samples it at an interval of 1024 at the moment. So if we double that and then we load the waveform again, you can see it's thicker now because it's analyzed more samples than it did previously. If you want it to display as a thicker waveform, we can click this here, so it just makes it a bit more clear, and then we can even double that thickness as well to make it even clearer. So that's the basics of how it works. That was my basic goal, but now I'll go over the implementation of it and some of the issues that I ran into while trying to implement this. So jumping over to the code, the first bit that we've got here is decoding the WAV file. Now this leans heavily on the David Reid public domain library for decoding WAV files. So this pulls all of our sample data, channels, etc. that we'll need for the waveform. And then when we've got all the data that we need, we'll do a few things with reserving the right amount of space in our arrays, and then we'll create a render target. So the way that it works is we have a material on the mesh, and inside that material there's a texture, and on begin play we'll replace that texture with the render target that we'll be painting with the waveform. So then coming down to here, we split the canvas into the amount of channels that we need. So if it's 2 channels, 4 channels, a mono channel, this will handle that. Then iterating through each of the channels, and then iterating through each of the samples for those channels. So depending on the amplitude of the sample, it will draw a vertical line, and then it will create this tile item and then draw the item to our canvas. And that's pretty much it for the first implementation of it. But now I'll show you the reason why this worked, but it also didn't work. Okay, so we'll load new waveform. We'll select the ambisonics recording, click open, and we'll wait. Then we'll wait for a bit longer. Will it do it? It's thinking about it, and there it is. So it does work. It draws our waveform, but it takes a very long time to do it. So if we stop this and I'll play in editor again, this time I'll make a trace of it. So if I load new waveform, ambisonics test, open that, and then if we stop and then stop our trace and then if we take a look at what's going on, so we'll open that trace. So if we zoom out here, and let's just see where it's taken the time to load. So this big block here is where, we'll just make this window a bit bigger. This big block here is where it's calling a function that I've got called file selector, which is opening the window for us to select our file. So it's waiting all this time for that. And then if we take a look at this frame here, so I've selected the file that I want and it loads it. And then if we go down to the render thread, so actually the frame before here, we've got this draw canvas to target. So this is what's giving us that big pause. It's all the draw calls from the tile item that we were creating and then drawing to the canvas for every single sample. So I needed a solution that would only create one draw call when the texture was created with the waveform on it. That led me to this implementation. So instead of using a render target, I'm using a UTexture 2D, and then we're getting the first bitmap from that UTexture, then locking it so we can write to it, and then as before, going through each of the channels, then going through the samples, and then for each pixel, if the pixel lies within the amplitude of the sample, we're going to paint that black, and if it doesn't, it's going to be white. So that's going to give us a white background for everything else other than the vertical bars for each sample. Then we're going to unlock that bitmap, update the resource, and then set that as the texture parameter in the material. So now instead of doing a draw call for each of the samples, it's creating the 2D texture and then creating one draw call. So now that should be a lot faster. This is how it performs with the new implementation using the 2D texture. So if we spawn in and then load the Ambisonics recording again and open that. So this time it opens and it draws a waveform pretty much instantly. So even testing that with a higher resolution, so let's times that by 4, load the waveform again, and still it was pretty much instant. So it's a lot quicker than the render target. If we zoom in here, we can see it's drawn a lot more samples than it did at the lower resolution as well. The last thing I wanted to go over was the waveform thickening. So I've got the mono waveform here, and if I zoom in and then select use texture thickening and then use double thickness, this might be a more preferable view of the waveform if you were more zoomed out and you didn't want to see the individual samples. So the way that I'm doing this is just via this material. So I've got a few different instances of the wave texture here, and then I use these dynamic branches to select if to use the wave thickening or not, and then if to use the double thickness. So what this is doing is just looking at UV coordinates 0.5 either side of this current coordinate, and if either of those UV coordinates either side are black, it will also color this UV coordinate black as well. And that's it. That's how I created a waveform from a WAV file in Unreal Engine 5.